To my class of operating system. Today we will learn about disk scheduling algorithm. One of the responsibilities of operating system is to use the hardware efficiently. For the disk drive, meeting this responsibility entails having fast access time and large disk bandwidth. The access time has two major components, the seek time and the latency time. The seek time is the time for the disk arm to move the heads to the cylinder containing the desired sector. The rotational latency is the additional time for the disk to rotate the desired sector to the disk head. The disk bandwidth is total number of bytes transferred divided by the total time between the first request for the service and completion for the last transfer. We can improve both the access time and bandwidth by managing the order in which disk IO requests are serviced. The operating system is responsible for using hardware efficiently. For the disk drive, this means having a fast access time and disk bandwidth. Access time is two major concern. Seek time is the time for disk to move the heads to the cylinder containing the desired sector. Rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk. Minimize seek time is equals seek distance. Disk bandwidth is the total number of bytes transferred divided by total time between the first request for service and the completion of last transfer. If whenever a process needs IO or from the disk, it issues a system call to operating system. The request specifies several pieces of information, whether the operation is input or output. Second, whether the disk address for the transfer is not, or whether the number of sector to be transferred is. If the desired disk drive and controllers are available, the request can be serviced immediately. If the drive or controller is busy, any new elements or any new request for service will be placed in the queue of pending request for that queue. For a multi-programming system with many processes, the disk queue may often have several pending requests. Now, disk bandwidth is the total number of bytes transferred. There are many sources of disk IO request: operating system, system processes, user processes. IO requests include input output mode, disk memory address, number of sectors to transfer. OS maintains queue of requests per day or one after a day. OS maintains queue of requests per disk or device. Idle disk can work input output request. Busy disk means work must be in queue. Organization optimization algorithm only makes sense when a queue exists. If there is no queue, then there is no point of executing optimization algorithm. This is the component of disk transfer. This is a diagrammatic representation. Here the waiting for the device is there. Now waiting for the channel. Once wait for device and wait for channel is over, then there is seek time. After seek time, then there is rotational delay, and after rotational delay there is data transfer. Note that drive controllers have small buffer and can manage a queue of IO requests. Now we illustrate them with the IO request queue. This is the IO request queue. We will throughout the session we will continue with the same queue and perform different scheduling algorithm to see their performance. With the queue there are element 98, 183, 37, 122, 14, 124, 65 and 67. And head starts with at 53. Now types of disk scheduling algorithm. FCFS, shortest seek time first, scan or elevator, circular scan, C-scan, look, C-look. FCFS scheduling. The simplest form of disk scheduling is of course the first come first serve algorithm. This algorithm is intrinsically fair, but it generally does not provide the fastest service. Consider for example a disk queue with disk for IO 2 blocks on cylinder. Then consider the example of a disk queue with request for IO blocks on the following cylinder, the example which we have considered with the same queue. This is the diagrammatic representation of the queue. This is the diagrammatic representation. Consider that example, a disk queue with request for IO blocks cylinder in that order. If the disk head is initially at 53, it will first move from 53 to 98, then to 183, 37, 122, 14, 124, 65 and finally to 67 for a total head movement of 640 cylinders. This segment is shown in the diagram. Then we come to SSTF scheduling, shortest seek time first. It selects the request with minimum seek time from the current head position, also called shortest seek distance first, SSDF. It is easier to compute distances. It's biased in favor of the middle cylinder request. SSTF scheduling is a form of SJF scheduling, may cause starvation of some request. It seems reasonable to service all requests close to the current head position before moving the head far away to service other requests. This assumption is the basis of shortest seek time first algorithm or SSTF algorithm. This algorithm selects the request with the last seek time from the current head position. Since seek time increases with the number of the seek time increases with the number of requests. For our example, request queue, the closest request to initial head position 53 is at cylinder 65. Once we are at cylinder 65, the next closest request is at cylinder 67. From there, the request at cylinder 37 is closer than that one at 98. So 37 is served next. Continuing, we service the request at cylinder 14, then 98, 122, 124, and finally all of them. This scheduling methods result in a total head movement of only 236 cylinders, little more than one third of the distance needed for FCFS scheduling of the request clearly. Now we come to another algorithm, scan algorithm. The disk in scan algorithm, the disk arm starts at one end of the disk and moves toward the other end, servicing request until it gets to other end of the disk, where the head movement is reversed and servicing continue. It moves in both direction until both ends. It tends to stay more at the end, so more fair to extreme cylinder request. At the other end, the direction of head movement is reversed and servicing continue. The head continuously scans back and forth across the disk. The scan algorithm is sometimes called elevator algorithm, since the disk arm behaves just like elevator in a building, first servicing all the requests going up and then reversing request the other way. Let us return to our example. Before applying scan to schedule, the request cylinders were at 98, 183, 37, 122, 14, 124, 65 and 67. We need to know the direction of head movement in addition to the head's current position. Assuming that the disk arm is moving ahead and the initial position is at 53, head will next service 37 and then 14. If a request arrives in the queue just in front of the head, it will be serviced almost immediately. A request arriving just behind the head will have to wait until the arm moves to the end of the disk and reverse direction and comes back. This is the diagrammatic representation of scan algorithm or elevator algorithm. Assuming a uniform distribution of request for cylinder, consider the density of request when the head reaches one end and reversed direction. At this point, relatively few requests are immediately in front of the head, since these heads have recently been serviced. The heaviest density of request is at the another end of the disk. This request have also waited the longest, so why not go there first? This is the idea of the algorithm. Look, The disk arm starts at the first I/O request on the disk and moves towards the large I/O request on the other end, servicing request until it gets to the other extreme. I/O requests on the disk, whether the head movement is reversed and processed. It moves in both direction until both last I/O request more inclined to serve the middle cylinder requests. C-scan algorithm. Cluster scan or C-scan scheduling is a variant of scan designed to provide a more uniform waiting time. Like scan and C-scan moves the head from one pointer to from one end of the disk to the other, servicing request along the way. When the head reaches the other end from the disk, servicing request at its goes, when it reaches another end, it immediately returns to the beginning of the disk without servicing any request on the return trip. It treats the cylinder as a circular list that wraps around from the last cylinder to the first one. C-scan algorithm provides a more uniform wait time than scan. It treats all cylinders in the same manner. This is we can say this is the diagrammatic representation of the algorithm. We continue with the same process. Now C-look algorithm. Look version of C-scan. Arm only goes as far as the last request in each direction, then reverses direction immediately without first going all the way to end of the disk. In general, circular versions are more fair but pay with a large total seek time. Scan versions have a larger total seek time than the corresponding look versions. This is the diagrammatic representation of C-look algorithm, and the head starts from 53. Selection of a disk scheduling algorithm. Given so many disk scheduling algorithms, how do we choose the best one? SSTF is common and has a natural appeal because it increases performance over FCFS. Scan and C-scan perform better for systems that place a heavy load on the disk because they are less likely to cause a starvation problem. For any particular list of requests, we can define an optimal order of retrieval, but the computation needed to find an optimal schedule may not justify the savings over SSTF and SNDF. So, how to select? The performance depends on number and types of request. Request for disk service can be influenced by file allocation method. The disk scheduling algorithm should be written, allowed it to be replaced with a different algorithms if necessary. With low head load on the disk, it is FCFS. SSTF is common and has natural appeal, good for medium disk load. Scan and C-scan perform better for system that place a heavy load on the disk. Less starvation. Performance depend on number and type of request. Request for disk service can be influenced by the file allocation method and metadata layout. Either STF or look as part of elevator package is a reasonable choice from the default algorithm. Thank you. Hope you have enjoyed.